This problem is here so that we get some practice with handling scientific notation, which, remember, is used to denote very, very large or very, very small numbers by emphasizing the decimal portion of it along with what power of 10 gets you up to that big number. So 100 is 1 times 10 squared. 1,000 is 1 times 10 cubed. 1/10 0.1 is 1 times 1/10, or 1 times 10 to the minus first, and so on. I think you've seen the foundations of this before. We're just going to build on it and practice a little bit by finding out the average speed of the Earth. How fast is the Earth moving through space? This is a little mini geometry problem, because if we put the sun there and the Earth here, the Earth moves around the sun like so in a circle. The total distance around a circle is called the circumference, right? And the circumference is 2 times pi times the radius of that circle. And so we want to know, how long does it take for the Earth to cover that large distance? And we want that in miles per hour, which is a ratio of miles over hour. How many miles do we go in every hour? The distance that we're talking about here is the circumference of the Earth's path. We're pretending it's a circle. It's not quite a circle, but close enough. That total distance is 2 times pi times the radius of this circle, which is the distance from the Earth to the sun, and that's what we have right there. So 2 times pi times 9.3 times 10 to the 7th is the distance the Earth covers in miles. And then we're going to divide that by a term in hours that represents the duration of this trip. Well, it takes 1 year for the Earth to go all the way around like that. And so the Earth covers this circumference of 2 pi times the radius in 1 year. So what we would really like to do is indicate in this denominator the equivalent of 1 year, but we want to put it in hours so that our speed is in miles per hour, not miles per year. But again, we have that information. 1 year, 365 days, is 8.76 times 10 cubed hours. Now, this is not simplified by any means. So this is our practice with scientific notation. We're going to group the constant or the decimal parts of these numbers in the numerator. 2 times 9.3. Now, on a good day, I can do that in my head. That will be 18.6. And we're going to let pi be pi. Let's not let it lose its identity. Let's just keep it there. So the top is now 18.6 times pi times 10 to the 7th in miles. And in the denominator, we now have 8.76 times 10 cubed in hours. And we're still not done because we need to shake this out a little bit more. So I'm going to pop open a calculator and run some of these numbers. Now, what we're going to do with the calculator is we're going to find the value of 18.6 times pi over 8.76. And then in scientific notation, we'll bring along the trailing powers of 10. Now, we can do this part already. That's pretty simple. So 10 to the 7th over 10 cubed is 10 to the 7 minus 3. And so this final value will be equal to whatever number goes here times 10 to the 4th. And we're going to hope that this is a single decimal. If it's not, we might have to adjust things. But let's take a look. So here is a calculator. If I wanted to bust open a scientific calculator so that I could maybe use pi as pi, I might want to do that. Hey, there it is. Let's go ahead and use that instead, because otherwise we round off pi as 3.14. But when you round things off, you introduce error, and then if you start combining that number with more numbers, the error is going to magnify. So let's build this expression as 18.6 times pi, and then we'll close our parentheses, and then take that and divide it by 8.76. And that's equal to 6.67. What I would also like to show you is a little online gizmo. Gizmo really undersells this, but we'll go with that phrase, called Wolfram Alpha. The company Wolfram writes for mathematics utilities, a lot of different software. One of the features that they have is a web-based computational tool that you can use. Now the screen is kind of cut off here, but I don't need too much space. When we go to Wolfram Alpha, what we can do is just kind of free-form type in what we want to calculate, which is 18.6 times pi over 8.76, and then hit enter, and this will return the value that we're looking for. There is what we input, and then the 6.67 is again recognized as the correct answer. So we'll stick with it. We've used both the calculator and the online tool. Feel free to use Wolfram Alpha when you need to, if you need some help on problem solving. But yeah, that's it. We took our original expressions, 2 pi r, the total distance the Earth travels, the time it takes to cover that distance, that gives us the average speed in miles per hour, and from that point it was just shaking out the numbers, gathering the leading constants together, gathering the powers of 10 together, and letting it ride, finding a convenient way to calculate this cluster, and we end up with 6.67 times 10 to the fourth. And remember, if we write that out, okay, don't forget the units of this are miles per hour. When we write this out, the 10 to the fourth means that we're going to take this 667, the decimal was originally here, and we're going to go over 1, 2, 3, 4 spots, like so. And that means that the Earth is traveling at 66,700 miles per hour through space. So hold on.